Okay, so with the law of cosines, there were none of our homework problems. There wasn't any even to a sine where actually the law of cosines wouldn't have worked. It always worked. In fact, it could fail. It would never fail for a side angle side. If you know two sides and included angle, that means you know that much. And there's no way you couldn't connect the ends of those lines and make a triangle. I mean, it would never fail if you know a side and an angle and a side. And the only way that it fails for side, side, side is if the smallest two sides don't add up to more than the third side, right? We know that from geometry days, right? If the largest side is more than the sum of the other two sides, you don't have a triangle. Something like this. If A is 16 and B is 10 and C is 5, because these two sides don't add up to 16, there's no way to get a triangle, right? I mean, end to end, they don't reach the ends of that one side. Now, what does it look like if you tried to do law of cosines with something we actually already know is not a triangle? Well, you plug in to solve for an angle, and I'm solving for A, the biggest angle, and I plug in everything, and I get that the cosine of A equals negative 1.31. Okay, at that step, you know there's no triangle because cosine can't equal a number bigger than 1 or less than negative 1. Right? So when any of these things fail, that's how it fails. You end up with a sine equals something bigger than 1 or less than negative 1, or a cosine equals something bigger than 1 or less than negative 1. The thing is that hopefully if I gave you three sides that didn't add up, you wouldn't even have to do, you'd just say no solution. I could tell just by looking at them, there's no solution.